Hi everybody. Now I would like to discuss the types of solvents. This is Dr. T. Antony Santosh, Assistant Professor of Chemistry, St. Joseph's College of Arts and Science, Cuddalore. This topic is especially for second BSc Chemistry, Inorganic Chemistry, and the subject code is SANDOSH-CH305A. And this is the flowchart which explains a different one of the different types of classification of solvents. The solvents can be divided into polar and non-polar solvents. The polar solvents can be further divided into protic and aprotic. So this is one of the classification, and the solvents can be classified in other manner also. Now let us discuss a few types of solvents. First type is polar solvents. By the name itself, we can understand the meaning. Polar solvents are the solvents that contain partial positive and partial negative charge. Or we can say they must have a dipole moment. A dipole moment means two different charges creating a moment. Okay. So the dipole moment occurs during the charge separation. And in the case of polar solvents, they generally dissolve other polar substances, as polar solvents generally carry a positive and a negative charge. And when we add a polar substance, the negative charge of the polar substance goes to the positive charge of the solvent, and the positive charge of the polar substance goes to the negative charge of the polar solvent, so that polar substances can dissolve in polar solvents. This comes actually from the famous saying, like dissolves like. That sentence, that saying suits to this property very much. So examples of polar solvents are water, acetone, methanol, etc. So these water, acetone, methanol and other things having the dipole moment, that means they possess the charge positive and negative. So this is one of the way how the polar solute in a polar solvent dissolves. This diagram, as we have seen, ionic crystal lattice, when it is added with a polar solvent water, and the positive ion is surrounded by negative ions and the negative ion is surrounded by positive ions, so hydrated ions dissolves, that what we have, the positive end of water surrounding the negative ion, the negative end of water surrounding the positive ion. So you could easily find how beautifully it surrounding and makes the ions to dissolve, that like dissolves like. Polar solute in a polar solvent dissolves. Next we can see what are non-polar solvents. It is just the opposite of polar solvents. Non-polar solvents, electric charge in the molecule of non-polar solvents is evenly distributed. There will be charge, but it is evenly distributed. There will not be dipole moment, positive end, negative end, positive pole, negative pole. There we cannot find anything like that. Therefore, the molecules have low dielectric constant. Their dielectric constant value will be very low. Non-polar solvents are hydrophobic, immiscible with water. Non-polar solvents are lipophilic, as they dissolve non-polar solvents, substances like oils, fats, grease. These are all non-polar substances. They don't have charge. They have only very low dielectric constant. Okay, so this is also construct to the saying like dissolves like. Okay, so non-polar solvents are having these type of behaviors. Non-polar solvents are solvents that do not have dipole moment, as we have seen, are do not contain any partial positive and partial negative charge. If nonpolar solvents atoms come by forming a bond and the atoms have less difference in electronegativities, nonpolar solvents do not dissolve in polar substances or polar solvents as they do not carry any charge. So the first criteria for dissolving in a polar solvent, the substance should have polarity. So here in this case, non-polar substances also, since they don't have any charge, they cannot get dissolved in polar solvents. Non-polar solvents are dissolved in non-polar compounds like alkanes and aromatic compounds, since they are neutral to each other. And we can see some examples like benzene, toluene, and hexane. These are all examples for non-polar substances. So this is the way how the non-polar substances or solute gets dissolved in non-polar solvents. We can see here without any charge there may be any shape of molecules, and here the non-polar solid weak intermolecular force, there will be force but there will be low dielectric constant like force, and because of that there will be dissolving is given as we have seen in the picture. So the non-polar solute with non-polar solvent. Next, protic and aprotic solvents. A simple word, we can see H plus as protons. So from the word H plus or proton, we can say that protic and aprotic. So what is protic? Protic solvents have OH and NH, and they can form hydrogen bonds. OH, NH. So the hydrogen bonds of oxygen and nitrogen mainly. Aprotic substances or solvents may have hydrogen atoms on them somewhere, but they are not directly attached to oxygen or nitrogen. Lack of oxygen hydrogen bond, nitrogen hydrogen bond, and therefore cannot do hydrogen bonding. So protic forming hydrogen bonds, and aprotic there will be no hydrogen bonds. This is the main thing what we can see in the case of protic and aprotic solvents. So here we have a classification or a number of examples. In the case of protic, water, formic acid, acetic acid, ammonia, methanol, ethanol, hydrogen fluoride, hydrochloric acid, all of them are having protic, since they could make hydrogen bonding. They could make hydrogen bonding. But there are some other set of solvents which cannot make hydrogen bonding directly. There will be hydrogen in their molecular structure, but there will be no formation of hydrogen bonds. In the case of acetone, ethyl acetate, DMSO, DMF, THF, oxolane, HMF, crown ethers, acetonitrile, and other things. Okay. So next we have to see two important things: amphiprotic and amphoteric. Amphiprotic substances are substances that can act as either acid or base, since they can both donate or accept proton. So amphiprotic means they can act as either acid or base, since they can donate and accept proton. An amphiprotic species is a species that can act as either as an acid or base. Example, HCO3 acts as an acid in the presence of OH, but as a base in the presence of HF. Anions with ionizable hydrogens such as HCO3 and certain solvents such as water are amphiprotic. Okay. Amphoteric example, accepts proton and donates proton. Here water accepts proton to become H3O and donates proton to become OH. So amphoteric compounds means both is a molecule or ion that can react both as an acid and as a base. One type of amphoteric species are amphiprotic molecules which can either donate or accept a proton. This is what amphoteric means in Bronsted-Lowry acid-base theory. Examples are amino acids and proteins which have amine NH2 and carboxylic acid COH groups and self-ionizable compounds such as water. So we have seen now solvents, polar and non-polar solvents, protic and aprotic solvents, amphiprotic and amphoteric substances. Thank you.